All right, my friends, and here we are, the last lesson of our units on exponentials and logarithms, and we're going to conclude with a lesson on solving logarithmic equations. All right, and this lesson really is just going to combine several things that we've talked about in this unit, from properties of logarithms to inverses, some of those types of things. So what I would like you to do is look at number one. So there is a logarithmic equation there, log base 3 of 81 equals x minus 4. And see if you can figure out how to solve that and figure out what x would have to be for this to work. So let you have a shot at that. Flip the video back on and we'll see how you did. All right, so I have the work right here. Now, so the way you could think about this is use what we already know about logarithms, and we could rewrite it as an exponential equation, right? So we know that this is the base of the exponent. We know this is the exponent and this is the result. So if I do that and write it as an exponential equation like we've discussed, I get 3 to the power of x minus 4 equals 81. And by doing this, it puts it into the exact same type of problem we talked about last time. So now I can get the right side in terms of base 3 because 81 is 3 to the 4th power. The base is matched, therefore x minus 4 has to equal to 4. So that means that x has to equal to 8. All right, so really that's really the approach we're going to take for the first type of problems that we're going to solve today is let's just rewrite them as an exponential and then use what we already know, all right, to solve those equations. All right, so isolate that logarithm if we need to. All right, so we want that logarithm to be by itself. Use inverses to rewrite the equation, and then we're going to solve for our variable. So when I look at number 2 here, all right, I can see, all right, that the logarithm on the left is isolated. All right, so I know my base is 7, my exponent is x plus 5, and it has to equal to 49. So 7 to the x plus 5 has to equal to 49. And then what I know is 49 is 7 squared. So I can get that right side in terms of base 7. So that's 7 squared, which means that x plus 5 has to equal to 2, which means that x had to be negative 3. All right, and it really is that simple. Now, let's look at number 3. Now, there's only one piece that we have to add to this is whenever the variable is part of the argument. So whenever we're taking the log of that variable. The difference between solving a logarithmic equation and an exponential equation is that when we solve an exponential equation, there are no domain restrictions. So we don't have to worry about what type of values we get out. That's not the case with logarithms. We do have a domain restriction. And remember, our domain starts where our vertical asymptote would be. So we take whatever's in our argument here, we look for that horizontal shift, and we can do that by just taking the argument and setting it equal to 0 and solving. And so what we know is the domain for this particular logarithm would be negative 2 to infinity. Now what that is telling me is that my solution has to be greater than negative 2. If I get something that's not greater than negative 2, I wouldn't be able to have a solution, so I'd have a no solution problem. Now, once again, once we figure out what our working domain is, now we can get into the solving. So notice on number 3, my logarithm is isolated, so I can go ahead and say I have base 4. This is my power to the power of 2 equals to x plus 2. And now notice when I get to this problem, all right, it's not nearly as complicated as the prior problem because 4 squared is 16. So 16 equals to x plus 2, which means 14 is equal to x. All right, and notice that 14, all right, falls in our domain, so we know it's a good solution, so we're all good. All right, so now looking at number 4 together, once again, we'd have to find our vertical asymptote, and we do that by taking whatever's inside, right, that argument, and we just set that equal to 0 and solve, and that's going to give us our vertical asymptote. So that means 2x is equal to 1, right? X is equal to 1/2. So we know that our vertical asymptote would be at 1/2. So that means our working domain, based on everything we've talked about, would be from 1/2 to infinity. So we have to have something greater than 1/2 all right, when we solve. Now, once again, our logarithm is isolated, so we can go ahead and start writing it. So this is 5 to the third power, right, is equal to 2x minus 1, right? All right, so now I can just solve for x. I can add 1 to both sides. Now, when I do this, 5 to the third isn't too terribly large. Now, if it was something like 6 to the 28th or something like that, you could leave it as an exponential. But since this isn't too bad, 5 to the third is 125 plus 1 is 126. But if that were like a super large number, all right, you could leave it in terms of the exponential and just write it like that. So you could technically write it as 5 to the third plus 1, and that would be fine. And then my last step is I just divide this by 2, and I get my final answer is 63 is equal to x. All right, and that's really what we have. All right, so what I would like is for you, all right, to try problems 5 and 6 there. Remember, start with that working domain, write that down. That way you'll have it in front of you. All right, so let's see how you did. So I worked 5 and 6 over here on the side. Now, notice my working domain for my natural log of number 5 would be 0 to infinity. There's no horizontal shift, all right? But I do have to do one additional step before I get into my exponential. I do have to isolate. So I have to divide both sides by 2. That gives me the natural log of 2x, natural log of 2x is equal to 6. Therefore, e to the 6th equals to 2x. And then once again, notice to solve for x, I just have to divide both sides by 2. Now here's an example of leaving it as an exponential, right? E to the 6th is some decimal, but there's really no need to figure that out. We can just leave it like that. E to the 6th divided by 2, and that's definitely a positive number, so we're good with our domain here. All right, now same thing here. Let's start with our working domain, x minus 4. All right, that means our domain would be 4 to infinity. All right, so everything has to be greater than 4. Now, divide both sides by -3 to isolate that logarithm. And then we have, once again, base e, so e to the -8.3 is equal to x minus 4. Add 4 to both sides. All right, and then we get this number. Now, here's what we need to understand, that if we have a positive base, which we have to by definition, this is going to be a positive number here. So it's a very small number, but it's a little bit bigger than 4, so we're okay with our working domain. All right, so that's the first type of problem that we're going to see. Now, the second type of problem, let me flip back to our first page here of notes. And let me scroll down to problem 7 and 8 here. All right. The second type of problem that we're going to see, all right, is that we're going to have to use some of our properties of logarithms. And we're going to have to condense one side or both sides of the equation to get us to a single log. All right. And so once we see this, all right, we want to go back to condensing, and I mentioned that in our video lesson earlier that there are certain times when we want to condense, and this is that opportunity. All right, so let me pause the video here. I'm going to try to get rid of this toolbar. It popped up here all of a sudden.